This video explains the concept and process of testing hypothesis for t-test for single population. A t-test for a single population is used to determine if the mean of a single sample differs significantly from a known or hypothesized population mean. It's a statistical method used to assess whether the mean of the sample is statistically different from the population mean. Here are the key assumptions of the t-test for a single population. First is random sampling. The sample data should be collected through a random sampling method to ensure that it is representative of the population. Second is normal distribution. The sampling distribution of the sample mean should be approximately normally distributed. Third is interval or ratio scale. The data used in the t-test should be measured on an interval or ratio scale. Fourth is homogeneity of variance. The variances of the observations in the population should be equal. Fifth is independence. The observations in the sample should be independent of each other. This means that the occurrence of one observation should not influence the occurrence of another observation. Let's now discuss the steps for hypothesis testing using a t-test for the mean of a single population. First step is, formulate the null and alternative hypotheses. We are testing whether a sample mean differs significantly from this population mean or not. Therefore, null hypothesis can be stated as mu is equal to sample mean. Whereas, alternative hypothesis can be stated as mu is not equal to sample mean for two-tailed test. For left-tailed test, alternative hypothesis can be stated as mu is greater than sample mean, and for right-tailed test, alternative hypothesis can be stated as mu is less than sample mean. Second step is, choose the significance level, alpha. Common choices for alpha include 0.05 and 0.01. This signifies the probability of rejecting the null hypothesis when it is actually true. Third step is, determine the critical region. Based on the alternative hypothesis and the significance level chosen, find the critical value or values from the standard normal distribution table. Fourth step is, collect data and calculate the sample mean and standard deviation. Collect a sample from the population and calculate the sample mean and the sample standard deviation. Fifth step is, calculate the t-value. The formula to calculate the test statistic, that is t-value, is, t is equal to sample mean minus population mean divided by standard deviation divided by under root n. For a single sample t-test, the degrees of freedom is equal to n-1. Sixth step is look up the critical value from the t-distribution table corresponding to the chosen significance level and degrees of freedom. Alternatively, use statistical software to find it. Seventh step is, make a decision. Compare the calculated t-value to the critical value. If the calculated t-value falls in the critical region, or it is greater than the critical value for a one-tailed test, or falls outside the interval defined by the critical values for a two-tailed test, then reject the null hypothesis. On the other hand, if the calculated t-value is less than the critical value for a one-tailed test, or falls within the interval defined by the critical values for a two-tailed test, we can conclude that we fail to reject the null hypothesis. Final step is draw conclusion. Interpret the results in the context of the problem and make a conclusion. If the null hypothesis is rejected, it suggests that there is sufficient evidence to support the alternative hypothesis, indicating a significant difference between the sample mean and the population mean. If the null hypothesis is not rejected, it suggests that there is not enough evidence to support a significant difference. Thank you for watching. Don't forget to like, share, subscribe and hit the bell.